So in this video we'll be integrating trigonometric functions using the power reducing formulas which are stated here, which is sine squared x is equal to half into 1 minus cosine 2x, and cosine squared x is half brackets 1 plus cosine 2x. So these are the two formulas that you need to memorize and keep in your mind. Let's do some examples and this will be more clear to understand. So if you watched my previous video, we use u substitution with the formula of sine squared plus cosine squared x is equal to 1, and we kept on substituting sine squared with 1 minus cosine squared x and using u substitution. But in this example the question is to integrate sine squared x. Now if we replace sine squared with 1 minus cosine squared x, that's not going to help us, and in this case we need to use the power reducing formulas. So as recall, let me paste the formulas over here. So sine squared x is equal to half into 1 minus cosine 2x. Let's replace that here. So integral of half into 1 minus cosine 2x. Oops. Let's bring the half outside so it's more easier to integrate it. And now this is equal to, the integral of 1 is going to be x, and the integral of cosine is sine 2x over the derivative of the angle. So the derivative of 2x is going to be 2, so it's over 2, and plus c. Now we can leave it as this, or we can simplify it more and just write half x minus sine 2x over 4 plus c. So this is the final answer. Let's move on to the next example, which is the integral of cosine squared 4x. So one thing to notice is the angle. So it's going to be 4x, and if we go back to our formula, the formula says cosine x is equal to half 1 plus cosine 2x. So whatever the angle is, we multiply by 2. So when we use the power reducing formula here, it's going to be equal to, I'm just going to take the half outside, and it's going to be 1 plus cosine 8x, since we are just multiplying it by 2. So now we just derive this, so it's going to be half into x plus sine 8x over 8 plus c, and we can simplify this now, half plus sine 8x over 16 plus c. So let's move on to a more complex example here, which is integral of sine x to the power of 4. So what do you think we should do first? We need sine squared x to be able to use the power reducing formula. So what we can do here is we can write it in this term, which is going to be sine squared x, and we can take another square outside. Now we can replace this part with this over here, and let's do that. So it's going to be equal to integral of half into 1 minus cosine 2x, and there's two brackets over here, so I'm gonna take the other brackets as square so it's more clear, and there's a squared on top of everything here, dx, and we can square the half and take it outside, so it's going to be 1 over 4 integral of 1 minus cosine 2x squared dx. And to simplify this, it is basically a minus b squared, and what that is just integral of a squared, which is 1 squared, minus 2ab, so 2 times 1 times cosine 2x is going to be 2 cosine 2x, plus b squared, so it's going to be cosine 2x squared. So cosine squared 2x, close brackets. Actually we don't need to use brackets anymore, so I'm just going to take it out. Now if you notice something here, we have a cosine squared 2x. So we need to use the other formula for power reducing formula for cosine, which is cosine squared x is equal to half 1 plus cosine 2x, and we realize that the angle here is 2x already. So when we reduce it more, it's going to become 4x. So let me just clear some space and write it here. So now it's going to become 1 over 4 integral of 1 minus 2 cosine 2x plus, now let's actually distribute the half because it's going to make it more simpler. So it's going to be half plus cosine 4x. So you need to be very careful for the angle every time. It's just going to double every time whenever you're using the formula. And it's going to be over 2. Now we can just integrate it normally. So I didn't write dx here and here. So now it's going to be equal to 1 over 4. The integral of 1 is x minus 2 cosine, oh, not cosine, 2 sine 2x over 2. So we can just remove the extra 2 over here, plus half is just 1 over 2x. Actually, yeah, let's remove this and simplify it over here. So it's going to be 3 over 2x basically. And the integral of cosine 4x is going to be sine 4x over 2, it's already there, times 4. So this is over 8. So this is over 8 plus c. And we can leave it as this, and we can distribute the 1 over 4 and simplify it more. But yeah, so this is the final answer. So for our last example, we have the integral of sine squared x times cosine squared x. So the first step that we can do here is we can use both of the power reducing formula and write integral of half, and sine is 1 minus cosine 2x, and then half again, open brackets, 1 plus cosine 2x, close this bracket. We can take 1 over 4 because half times half is 1 over 4, so we can take 1 over 4 outside, and this is basically a minus b times a plus b, which is a minus b squared. So it's going to be 1 minus cosine squared 2x dx. And if you realize something here, it is 1 minus cosine squared. So 1 minus cosine squared is an identity which is equal to sine squared. Let me just write it here quickly. That's cosine squared x is equal to 1. And it does not matter what angle it is, it could be anything, but the other angle will be the same then. So here we can just do 1 over 4 integral of sine to 2x because we have 2x over here dx. Now again we need to use the power reducing formula, which is this one, and it will be equal to 1 over 4 integral of half 1 minus cosine 2x. We can take 1 over 2 outside, so it's going to become 1 over 8. And now we can finally integrate this and equal to 1 over 8. I made a small mistake here. The angle is going to be half, so always keep track of it. And this is actually a very common mistake of what students actually do. And obviously, like, if you keep using half angle formula, power reducing formula again and again, you will forget to divide the angle by 2. Anyways, so it's going to be 1 over 8. Integral of 1 is just x minus sine 4x over 4 plus c, and this is the final answer. Now I do have a shortcut method on the calculator where you can recheck your answer basically. So what we can do is, after getting the final answer, we go to the integral and we can put any two numbers. So on your calculator you can just put 0 and 1 and find the final answer for this. So it will give you, let's say, 0.3. And when we go to our final answer, we can substitute 1 first. So in the x is going to be 1 over 8, 1 minus sine 4, because it's going to be 1 over here, over 4, and then minus, then we substitute 0 next. So we minus the entire thing, and if you get the same answer here, that means that your answer here is correct. So I will make a short video on that, and that will be more simpler to understand. And yeah, thanks for watching.